Okay, we're not going to get much more into acids and bases and their chemical properties because there's a lot we can learn about acids and bases. We're not going to get really into that right now. We're going to learn how to name them for right now, basically. That's as far as we're going to go. But acids in general are basically a proton donor, and that's how I want you to think of them right now. You can also think of them as an electron acceptor, but for our intents and purposes, I want us to think of them as proton donors. So if you donate something, that means you must have an extra of that, right? If you're going to donate something. Okay, so a proton donor, when we think of as a proton donor, we think of them as giving up a positive charge. Okay? And more specifically, when we think of them giving up that positive charge, we think of them giving up a hydrogen ion. That's what they're giving away. They're giving away a hydrogen. Because a hydrogen ion by itself is a +1 charge, right? That's all that hydrogen is. It doesn't have any neutrons. All it has is a proton and an electron. And if it has a positive charge, that means that it doesn't even have an electron. All it has is that proton. Does that make sense? So acids are compounds that have hydrogens they can give away. Okay? If they give away a hydrogen, then they become a base. And if they get it back, they become an acid. Okay, so there's this constant back and forth between acids and bases. We're going to deal just with really simple acids and how to name them today. Okay, so think of them as proton donors. They have to have hydrogens that they can give away. All right? So there's two types of acids that we're going to talk about. The first of which are called binary acids. Okay? Binary acids usually probably consist of how many elements? How many do we think? 2 elements. Okay, so they consist of 2 elements. And what does one of those elements have to be? Yeah, it has to be hydrogen. If they're going to give away hydrogen, it has to be hydrogen plus one other element. That's it. Okay? And usually this element is a group 17 element or a halogen. Okay? So when we think about binary acids, they're usually hydrogen plus one of our halogens. Okay? The second type of acid that we'll talk about is something called an oxyacid. Okay, what do you think they probably contain? Probably have to contain oxygen somewhere. So they are made up of hydrogen, oxygen, and one other element. And it's usually a nonmetal. Okay, these oxyacids are often formed from our polyatomic ions. Okay, so we might take phosphate and add hydrogens to it and make it an acid. We might take carbonate and add hydrogens to it and make it an acid. Okay, so that's where those are all considered oxyacids that are built from our polyatomic anions. Okay, do we understand the two different types of these things? Binary is hydrogen plus one other element. Oxyacid has to contain hydrogen, oxygen, and then some other element. Okay, that's usually a nonmetal. Okay, our oxyacids most of the time come from our polyatomic ions. That's not all the time, but it's most of the time. Okay, so let's look at how we're going to name these acids now. We're going to start with the binary acids. Okay, these are hydrogen plus one other element. And the way that we look at these binary acids, and the way that we put them together is we have to balance charges. Okay, so acids must have a neutral charge. This is all acids, not just binary. Okay. So let's say I want to build an acid between hydrogen and chloride. Okay? Hydrogen and chloride. Hydrogen's charge is always +1 because that's the proton, right? That's what we want to give away. So hydrogen is +1. What's chlorine's charge? Chloride, sorry. Chloride is -1. Good. So when we need to combine these to an acid, it looks just like this. HCl, that's it. Okay, does anyone know the name of this acid? Hydrochloric acid. Okay, have we heard that before? So the trick for naming binary acids, it looks like this. We start with the prefix hydro, and then the element, or the root of the element, and then it ends with ic acid. Okay, so hydrochloric acid. Okay, we take the root of that word, put it in the middle, hydro blank ic acid. Okay? Questions here? Has to have a neutral charge, so hydrogen's +1, chloride is -1. We call it hydrochloric acid. All right, so what if I wanted a acid between hydrogen and sulfide? Hydrogen and sulfide. Hydrogen is +1. Sulfide is -2. So how many of those positive hydrogen protons do I need to balance out the -2 charge? I need 2 of them. So it would look like this, H2S. Correct? Okay. We don't change the name at all. So it's still a binary acid. It still comes from an ide. Okay, right? It came from sulfide combined with hydrogen. So this name would be hydrosulfuric acid. Right? And you don't write it with the dashes in there. So we would call this hydrosulfuric acid. The reason that we use this hydroic acid is because it comes from an IDE anion. Okay, so the anion that gets paired with the hydrogen here is what? Sulfate, sulfide, what is it? Sulfide, right? It's just sulfur by itself. So this sulfide ion pairs with some hydrogens to form an acid. Because it came from an IDE anion, we name it with a hydroic acid, okay? And I'm going to give you a little table that you can keep with you that will give you these kind of clues that go with it, okay? Or you can also just understand that it's a binary acid. It's between hydrogen and one other element, so that's how we name it, hydroic acid. Okay? Clear there? Let's look at going backwards now. So give me the formula for hydrobromic acid. Hydrobromic acid. What do you think the root right here, brom, what does that need to go with? Bromide, right? And you probably want your periodic table of ions out if you don't have that out yet, but that's going to go with bromide. Okay, Morgan, what do you think? HBr, that's it. Right, bromide has a charge of what? -1, good. And hydrogen has a +1. Okay, so that's an easy balance. Give me the formula for hydrophosphoric acid. Hydrophosphoric acid. All right, Brett, what do you think? H3P. H3P. Perfect. Phosphide has a charge of -3. Hydrogen's +1. We need 3 of those to go together. You can do your cross-down method here, too. It works the exact same way. But here it's a little simpler because we're just dealing with hydrogen, which is always a +1. So we know exactly how many of those hydrogens to pair with that. Okay? Another good clue if we're looking at these compounds and we're not sure, is it ionic, is it covalent, what type of a compound is it? If it starts with hydrogens in the front, you can almost guarantee that it's an acid. Okay? When it starts with hydrogens in the front like that, you can almost always guarantee that it's going to be an acid. Okay? All right, let's move on to naming our oxyacids. Do we have any more questions with binary? Or we feel okay with that? Okay. Our oxyacids, we already said they're usually made from our polyatomic ions. Okay, so let's say we want to pair hydrogen and nitrate. So hydrogen and nitrate, which is NO3. What's the charge on nitrate? -1. Okay. So if I want to pair these together, is it going to be a pretty simple pairing? Yeah, right? It's 1 and 1. So that means it's going to combine together to look like this, HNO3. All right, so when we name our oxyacids, we have to, again, look at what type of anion did it come from, okay? And this is what type of anion, what's the name that goes with this? What's the name of this anion? Nitrate. So when it comes from an ATE anion, it's got a certain name that goes with the acid. Okay, so we have to pay attention to what the anion is. It came from an 8 acid, so that means that it ends with ic. That's it. No hydro, that just means it ends with ic acid. Okay, so we take the root, we end it with ic, which means this would be called nitric acid. Okay, so acid naming has a couple rules that we have to pay attention to and remember. If it ends with just an ic, that means it must come from an 8 anion. So that means it must come from nitrate. Okay? Questions here?
So nitric acid is the name of...
Nitric acid is the name of this molecule right here. Okay? And the reason we know it comes from NO3 is because when it ends with an ic, we know the anion that paired with hydrogen had to be an 8. So therefore we know it had to be nitrate. Okay? I know this is a little new and a little bit foreign. We'll keep doing a couple more examples. I want to look at now the difference between nitrate and nitrite. They're going to make 2 different types of acids. Okay? All right, so pair hydrogen and nitrite. Nitrite is what? NO2 minus 1. Good. NO2 minus 1. So if we're going to pair these, it's going to be a simple pairing again, but it's going to be HNO2. Okay, that's the only difference. And so now we look at how we name these, because these are 2 different compounds. HNO2 and HNO3 are very different compounds. So they have different names. So for this, it ends with an ITE, right? The anion that it came from ends in ITE, which means our acid ends with an OUS. Okay, so what would this one be called? Nitrous acid. Okay. So now we've got 3 different ways to name acids. If it comes from an IDE, it comes from an IDE anion, it comes from an 8 anion, or if it comes from an ITE anion. We've got different ways that we name those. So nitrous acid, if we see OUS, we know it has to come from the ITE anion of that. All right, so these take a little bit of problem solving, a little bit thinking. Give me the formula for carbonic acid. Carbonic acid. Okay, so let's think about this with the name first of all. The ending is with ic, IC. Okay, so that means it has to come from what type of an anion? An 8, which means it needs to come from a pairing between carbonate and hydrogen. Okay, do we see how we got there? The ic ending tells us it has to come from an 8 anion, and since it's carbonic, we know it has to come from carbonate. So now we want to look at a pairing between hydrogen and carbonate. What is carbonate's charge? -2. So how many hydrogens do I need to pair with carbonate to get a balanced formula? Good, I need H2CO3. That's carbonic acid. A formula that looks like this. Okay, so first of all, we have to determine, when we split these apart, we would be left with a hydrogen and a SO3. Okay, what's the charge that goes with this anion? -2. We know that because hopefully we know the polyatomic ion, but we also know if we crossed our charges back up, we would get a +1 and a -2. Okay, so what is this anion right here? Sulfite. So, if my acid came from a combination of hydrogen and sulfite, what would the name of this molecule have to be? Sulfus. This one is a little bit funky, but it's actually sulfurous. Yeah, it's interesting about when we take that ending of the word and when we don't. I don't know. But it's sulfurous acid. Okay, the OUS comes from the fact that it ends in an ITE anion. On your own then. Hydrogen and fluoride paired together, which means we name it hydrofluoric acid. Very good. For our second one, phosphoric acid. Callie, what'd you have? H3P. That's what you had? Okay. Not quite. Let's talk about why. Okay. Our ending on our acid is just ic. Not hydro, just ic. So if it ends with an IC, what type of anion does it have to come from? Has to come from an 8, right? It has to come from phosphate. So we need to pair this with phosphate. So we were close. What should our final answer be here? Sean, what do you think? H3PO4. Phosphate is PO4 minus 3. Phosphite is PO3 minus 3. Okay, so that's where that really comes into play. Knowing those polyatomic ions. Does that make sense why that's the case? How many of you had that? H3PO4. Okay, good. All right, our next one, hydroiodic acid. Julia, what'd you have?
I had
HOH. Okay. How many people disagree? Okay, or how many people agree? Okay, that's all right. OH is what polyatomic ion? Hydroxide. Hydroxide. This one is tough. Hydroic. So now we're looking for the root that says iode. What is that probably paired with? Iodide. Yeah, that's tough. Okay, so when we look at this, we want to pick out the other parts of it. Okay, that's a tough one. So what should be our final answer here? HI. Okay, because it's paired with iodide, just iodide. That's a tough one. Okay, if you have to underline things and circle so you can see where that root is, that's fine. Go ahead and do that. All right, and our last one, what do we have? Alex, what'd you have? Chlorous acid. That's perfect. Chlorous acid. Okay, because the ClO2, what polyatomic ion is that? ClO2, is that chlorate or chlorite? Chlorite. Chlorite. So that means it has to end with OUS, our acid does.
Why is there no hydro?
Okay, so let's look at... Oops. I want to do... Okay, good. HNO2. Claire, what'd you have? Nitrous acid. Perfect. Perfect. Okay. HBr. Connor, what'd you have?
Hydrobromic acid.
Perfect. Hydrobromic acid. And our last one, acetic acid. Storm, what'd you have?
HC2, or HC2H3O2.
Very good. Okay, we don't just add that like hydrogen in the middle there. We can't say C2H4O2. That's not how it works. Okay? Sometimes you'll also see acetic acid written like this. CH3OOH. Okay, you'll see it written like that too. And acetic acid is sometimes written like this. Nope, I'm missing a C. CH3COOH. Okay? And the reason it's written like this sometimes has to do with the way acetic acid is bonded together and the way that the chemical formula looks. So when we see acetate, it looks like this. Okay? Here's CH3 over on this side. Here's C bonded to two oxygens, and when it's acetic acid, the H just goes right over here. So the way they write acetic acid has to do with the way that it's bonded. So sometimes you'll see it like this, okay, which is the same as C2H3O2. Okay, so just kind of, that's really the only one that gets written differently, so I just wanted to show you that. But sometimes you'll see acetic acid written like that, and you might even see acetate written just like this with its -1 charge. Okay, and the only reason it's written like that is has to do with the way that those atoms are bonded together. Okay, but very good. And we're going to tell, is it ionic, is it covalent, or is it an acid? Okay, so now when we talk about these, I want you to first identify, is it an acid or a covalent or an ionic, and then I want you to name it correctly. Okay, so we got 4 up here. It's an acid, good. Okay, and do I have a volunteer for giving me the name of that? Yeah, Jaden, what do you think?
Hydroiodic acid.
Perfect. Hydroiodic acid. Good, I know we went through that one before. This next one, PBr3, do we think it's ionic, covalent, or an acid? Covalent, good. Okay. Do I have a volunteer here? Preston, what do you think?
Phosphorus tribromide.
Perfect. Phosphorus tribromide. Okay, because phosphorus and bromide are both on the right side of the periodic table, to the right of that stair step. They're both nonmetals. They're both anions. That's perfect. We don't give a prefix to that first element if there's only one of them, right? And we've only got one phosphorus atom. Very good. The next one, GES2. Do I have a volunteer? Is it ionic, covalent, or an acid? Ionic, good. Okay. And do I have a volunteer here? Yeah, Stone, what do you think? Germanium sulfide. Raise your hand if you agree. Yeah, perfect. Germanium sulfide. It's not germanium sulfate. It's not germanium sulfite, right? It comes from just the sulfur ion by itself. It just comes from sulfide. Okay? Very good. Germanium has to be what charge? What's germanium's charge? +4, right? So we have to have 2 of those -2 sulfur ions to match up with that. Very good. Germanium sulfide, good. And our last compound, ionic or covalent? Ionic, good. So this is a little bit of a funky one. Okay, it's ionic. What charge does hydrogen have to be taking on in this case to pair with that? Has to be taken on -1. Very rarely that happens, but it does sometimes. So what would we call this? Potassium hydride. Perfect. Very nice.